All right, here is studying the equilibrium of iron 3 and thiocyanate. I've made the 3 test tubes. You can see them labeled 1, 2, and 3. And now I'm going to be adding 10 drops of iron 3 to test tube 1. So 20, 1, 2, that was about 20 drops. And I'm going to mix it. Test tube 2, I need to add 20 drops of potassium thiocyanate. So 20 drops there. Again, mix it up. And then to test tube 3, going to add 20 drops of distilled water. Ish. So you can see, whoop, if we compare test tube 1, 2, and 3, that dark red color comes from the complex ion formed between iron and thiocyanate. And you can see that test tubes 1 and 2 are darker than test tube 3. All right, so here we're looking at the equilibrium of nickel and ammonia. So you can see here nickel nitrate is kind of green in color. I put the bottle right here so we can look at that color. So nice and green. Now I'm going to be adding 6 molar ammonia, dropwise, maybe, till I get a color change. Sorry, my dropper here is not working well. There we go. So, let me mix this up. If you look at it now, you can see it is clearly lavender instead of green. Maybe you could call it bluish. It's up to you what color you put. Then, I'm going to add some hydrochloric acid until I get another color change. Oh, this dropper's better. Maybe another drop. There we go. And you can see that the color has changed back to greenish. All right, next we have the reaction, the equilibrium involving methyl orange. So methyl orange, whoop, looks like this. See how in the test tube, or sorry, in the bottle, it's a very orange color. Now, your book had me make a acid solution and a base solution. When I added, so water indicator and the acid solution, you can see that the color went from orange to kind of a reddish orange color. Next, I'm going to add drops of the dilute base solution until the color changes. So here's my dilute base solution. And I'm going to add drops until the color changes. So didn't get many drops in there. Hang on. There we go. Dilute base. Add some more drops. There we go. Let me mix it up a little so you can see my color has changed really to almost a yellow orange, I would call it. See? Now it wants me to add drops of the dilute acid solution until the color changes again. So here's my acid. My drops. Oops, sorry. And you can see as it disperses through, the top is now kind of reddish. I didn't add enough to fully change the color. Let me add a little bit more acid. There we go. A little bit more. And after I vortex it, you can see my color has changed fully to red. It might change even more. Let me see if I can get a little bit darker. Add another drop or two. It's about as red as it gets. So, with acid, red, with base, or neutrally it's orange, and then with base it goes to kind of yellow-orange. All right, this part is looking at the calcium hydroxide. So I have my calcium hydroxide solid in water here. You can see it's cloudy. That means that there's a solid in there. It's a suspension, not a solution. If I left it, it would settle. You can see here the rubber thing I used to scrape it has the solid on there. Now I'm going to add some hydrochloric acid. There we go. And you can see, woo, it's steaming a little. That was pretty concentrated hydrochloric acid. It reacted, the hydrochloric acid reacted with my sodium hydroxide, or not sodium hydroxide, calcium hydroxide, and pulled the hydroxide ions into solution and the calcium to calcium ions. And now if I add sodium hydroxide, whew, you can see I can push the reaction. So here I haven't quite pushed it all the way. Add a little bit more. There we go. I've pushed the reaction the other way by adding more hydroxide ions to my solution and pushing my equilibrium back to the left. All right, this is the part testing the equilibrium between cobalt and chloride. So here is the cobalt solution before the addition of the hydrochloric acid. You can see it is a nice pinkish color. Then the instructions say to add some, it says 5 drops of 12 molar hydrochloric acid. In my experience, sometimes this takes more than 5 drops. Oh, come on. There we go. Where's my, okay, so 1, 2, 3, 4, 5. Okay, let me stir that. Nope, that wasn't quite enough. You could see the blue color had showed up, but it did not stick around. And you want that blue color to be permanent for this. Come on, nope. There we go. So, permanent blue color. There it is. Put the lid back on that. Whoop. There we go. You can see this has turned blue. Now, it says to add 5 drops of distilled water. So here's my distilled water. Whoop. We're going to call that 5 drops. And you see if I shake it, my blue color went away. Now it is back to pink. So if you change the concentration by diluting it, it goes back to the pink color. It shifts it back to the cobalt, which is pink, instead of the complex ion. Then it says place the test tube in boiling water. So if you see over here, I have some boiling water. Ooh, that's hot. Let me find my clamp. That will be easier. Should have thought of this ahead of time. There we go. So we'll put it in the boiling water. Let me adjust my camera a little. Ooh, and you can see pretty quickly there, it has turned blue. You can see that nice blue color when I add the heat. And then if I stick it in an ice bath, and wait just a minute, you can see there in the bottom where it was icy, it's starting to turn back to purple or pink or whatever, more pink. So there you go, back to pink with the ice. I could stick it back in my boiling water and push the equilibrium back to the blue complex ion. There we go, back to the blue. Back in the ice. And change it back to the pinkish purple color. So all I'm doing is using LeChatelier's principle. There we go. Pink on the bottom where it was in the cold, still blue on the top where it was warmer. So LeChatelier's principle.